Hello children, most welcome to all of you in my online chemistry class. In my previous lecture, you have studied about the crystal field splitting energy in an octahedral crystal field as well as in tetrahedral crystal field, and how the splitting of energies in the form of T2G and EG can be represented, that have been discussed in previous lecture. So in the continuation of the same topic, that is coordination compounds or complex compound, in today's video lecture we are going to study one more point related to crystal field theory, that is pairing energy and how crystal field splitting energy can be calculated. Alright, and on the basis of these 2 points, how the electronic configuration of a complex compound can be written. So these points we will study in this very lecture. So let's start with pairing of energy or pairing energy. So listen sincerely, what is the definition of pairing energy? So pairing energy is the energy required for electron pairing in a single orbital is called pairing energy. Listen once. Pairing energy can be defined as the energy required for electron pairing in a single orbital is called pairing energy, and it is denoted by letter P, and the value of this pairing energy as P depends upon the crystal field splitting energy in octahedral complex as well as the strength of the ligand. How it depends? So first condition you should note down, if the value of this octahedral crystal field splitting energy, children, this del represents what? Crystal field splitting energy. This you can read it, actually this is O, means this is octahedral complex. This symbol is generally denoted O, and it is a subscript for octahedral complex, but you can read it is del 0 or del O or del octahedral. In the case of tetrahedral complex, this O will be changed into T, small t, and in that case it is called del T or tetrahedral complex. So no doubt this O stand or 0 stand here for octahedral complex. So first condition arises that if the value of del 0 is less than P, and that is for a particular ligand, then it is called weak field ligand. Must remember. Then this is called WFM, means weak field ligand. Listen, first condition, if the value of del octahedral or del O or del 0 is less than P, that is for a particular ligand, then it is called weak field ligand. Alright, and second condition, you can represent if the value of del octahedral or del O is greater than P, and that is for a particular ligand, then it is called a strong field ligand. So just we have to implement this point in the calculation of cfsc, and also we will apply this fact in the writing of electronic configuration of a complex compound, in the writing of electronic configuration of complex compound. So first condition is, if the value of this del 0 or del O is less than P, the field will be weak, called weak field legend, and if the value of del 0 is greater than P, it is called a strong field legend. And the concept of weak field and strong field I have already discussed in the detail about spectrochemical series. And in that I have told you that spectrochemical series is the arrangement of legends in the order of their field strength, increasing field strength, or in the order of increasing crystal field splitting energy. So keeping that point in knowledge, you can here implement that, or you have to understand that or make the concept clear. If the value of this del 0 is less than P, the legend is said to be of weak field. If the value of del 0 is greater than P, the legend is said to be of strong field legend. Now, how the crystal field splitting energy can be calculated. So, keeping all these points in mind, children, you have to know one formula, and by the use of this formula, you can easily evaluate the value of crystal field splitting energy. So, from previous knowledge, you are knowing that when electron occupying in T2G orbital, listen, when electron occupying in T2G orbital, the energy is decreased by minus 0.4 del 0. Must remember, when electron occupying in T2G orbital, then there is a decrease in energy by minus 0.4 del 0, and this 0.4 is coming from where? From the beginning of the lecture I have told you that in T2G field it is 2 by 5 del 0, okay, and if you divide it 2 by 5, if you divide, that will no doubt it will come 0.4 del 0. Am I right, children? Similarly, in the case of EG, I have told you that, according to the concept of crystal field, EG is a 3 by 5 del 0. Okay? EG is a 3 by 5 del 0, and if you divide 3 by 5, so that will come 0.6. So in decimal form, these 2 by 5 and 3 by 5 values can be written as 0.4 and 0.6 respectively, and they are showing the energy level. This showing the lower energy level in octahedral complex, and this showing higher energy level in octahedral complex. So from this point, this minus 0.4 is a reset. Alright, children? So, and in the case of EG orbital, this value is plus 0.6 del 0. Keeping these 2 points in knowledge, one formula is given for the calculation of CFSC. So now CFSC, crystal field splitting energy, can be calculated by this formula minus 0.4 X plus 0.6 Y, and this is for octahedral complex. Listen, formula is minus 0.4, this is 0.4 X plus 0.6 Y, where X represents the number of electrons present in T2G orbital. Listen, where X represents the number of electrons present in T2G orbital, while Y represents the number of electrons present in EG orbital. This is the key point, children. For the calculation of crystal field splitting energy, we have utilizing the formula minus 0.4 X plus 0.6 Y, in which the value in which the X is the number of electron present in T2g orbital and Y represent the number of electron present in EG orbital. Alright. So keeping this point in knowledge, now we are in position to calculate the crystal field splitting energy in different d orbitals. That can be calculated by constructing a simple table which consists following columns. Listen, for the calculation of cfsc of a complex compound in octahedral field, a table can be constructed, and this table contains following columns. In first column write metal ion configuration. Second column will be that is strong field ligand. And for strong field, the value of del 0 is greater than P. Okay. Second point will be crystal field splitting energy. Okay. And next column will be that is weak field ligand. And for weak field ligand, the value of del octahedral is what? Less than P. And last column will be the calculation of cfsc for weak field ligand. So we have to make such columns that will be easier for us to explain the cfsc calculation. Suppose children, we have to find the D4 metal configuration. What will be its strong field? How it will be calculated in the form of cfsc. So listen, in the case of D4, and in D4 it is a strong field ligand. So you are knowing that in strong field ligands, suppose this is your this representing T2g and this representing EG. Okay, two energy levels are T2g and electrons filled here according to Hund rule. So electron will go as here is D4. So that is what? This one, and this one, and fourth electron will be here. Means what configuration is coming? Coming T2G4 and EG0. So this will be the electronic configuration of D4 in strong field ligand. And on the basis of this formula, we just have written in the case of cfsc that minus 0.4x plus 0.6y. Now utilize this formula where x represents the number of electrons present in T2g and y represents number of electrons present in EG. So here electron present in EG 0. So cfsc will be for this will be minus 0.4 and the 4 electrons in T2g. So that x is multiplied by 4 plus what there is EG 0.6 into 0. So what value is coming? The value is coming minus 0.16. The value is what? Minus 0.16 is coming in strong field ligand. But in the case of weak field, what will come? It will be that is as such. This is your T2g orbital. This is your EG orbital. So electron will field as 1, 2, third electron, and this will go. So configuration become what? T2G3 and EG1.
Listen children, the configuration in the case of weak field of this D4 can be written as T2G3 and Eg1, and by using this formula the cfsc for D4 in weak field can be calculated as, this will be what? That is minus 0.4 into this children, 3 electron in T2G to 3 plus 0.6 into 1. So if you solve it, it is coming that is minus 1.2, that will come what? That is minus 1.2 plus 0.6, that is minus 1.2 plus 0.6, the value is coming what? That is minus 0.6. So this is the difference. In first case, this value is coming minus 0.16 and here is minus 6 for weak field agent. Similarly, in suppose we are going to write the electronic configuration of D5 in strong field as well as weak field. So go through the same. In the same way, this is weak strong field agent. So electron fields as, this is D5. So electron will be as such 1, 2, 3 and this is 4 and this is 5. So what become? This is T2G and this is Eg, and electronic configuration can be written as T2G5 and Eg0. This is the crucial point children, you have to know. And in the case of cfsc you have to find what will be this value. Go through the formula, minus 0.4 minus 0.4, X is the number of electrons present in T2G, there are 5 electrons in T2G, so minus 0.4 into 5 plus no electron in Eg, 0 electron, plus 0.6 into 0, so if you solve it, this will become minus 2.0. Is it children? And in the case of weak field, what happened? Listen, in the case of weak field, it will become as, this is your T2G and this is your Eg. So in the case of weak field, it will be written as, okay, this is 3 electron and this will go as D5. So configuration become T2G3 and Eg2, and its cfsc will be calculated as, cfsc for weak field will be calculated as, that is minus 0.4 into 3 electron is here in T2G into 3 and plus 0.6 I into 2. So what value? Minus 0.12 plus 0.12 and that become 0. Okay, so this way you can write. Similarly, D6 and D7 in strong field and weak field can be written in the same way. One thing you have to notice is, in the case of D2 and D3 coordination in tight, listen, in the case of D2 and D3 in tight, D electron will occupy only in T2G. Means in the case of, suppose we have to write D2 electronic configuration, it will be only T2G2 and Eg0. Okay. Similarly for D3 in tight, you have to write it, you can write it as, that is T2G3 and Eg0. So this will be the electronic configuration in the coordination in tight of D2 and D3, and D4, D5, D6 and D7 can be written in the same way. Alright, some question comes that write the electronic configuration of complex compound according to crystal field theory. Listen children sincerely. One more important point concerned to this T2G and Eg. Question is, find or write the electronic configuration of complex COF6 minus 3 in the form of Eg and T2G. So children, see here, this fluorine, according to a spectrochemical series, it is a weak field agent. So its configuration can be written as that. Oxidation number, if you find, CO will become +3 and its D electron will be in D6. So it is a weak field agent. So its electron can be, its electronic configuration in the form of crystal field theory can be written as, that will be T2G4 and Eg2. Okay, since it is a weak field agent, so it will be written as T2G4 and Eg2. Another example I am taking. Suppose we have to write the electronic configuration of complex FeCN6 minus 4. Then how you will write it? How you have to write? In this, children, since Cn is a strong field agent, so its oxidation state of this iron will be what here? It is +2 and will be in D6 state. So it is a strong field agent. So it can be written as, that is T2G6 and Eg0. So on this basis, the electronic configuration of complexes or complex compound can be written in the form of T2G and Eg, and many questions ask that write the electronic configuration of the given complex on the basis of crystal field theory. So children, do practice from models, and if any doubt you can ask. So this is all about electronic configuration of complex compound, and that is the way by which you can calculate the crystal field splitting energy. So this is all about CFSC, pairing energy and electronic configuration of complex compound. Thank you very much. God bless you. Stay safe.